All right, so when it comes to drilling, we're going to go through indexing, how you pick a surface to establish an index system so you can do 3+2 style machining. We'll also talk about how hole recognition is utilized with index systems for 5-axis drilling, and then an example of 5-axis drilling using the multi-axis drilling features. Okay, so those are the topics there. And again, what we're looking for here is to be able to find and locate holes on different faces of our part and be able to machine it in 5-axis versus having to set it up on a different part. We can use our 5-axis machine to rotate accordingly and be able to drill these different holes. All right, so just so you guys know, these example files, they come right from the help system within the software, okay? So you should have been sent a link so you can download the file and be able to work through it. The file that you'll download from the help system doesn't have any of the toolpaths on it, so you'll have to add the toolpaths. Now, I do recommend you work with these sample files because they are written up in the help system, and then also we're covering them in today's event. All right, so before I really get started, I just want to get some quick feedback from you guys. I know we have a handful of people in here today. A lot of the names here I do recognize. So I'm just curious, with the group that we have here today, what brand do you have a 5-axis machine or not? Okay, if you do have a 5-axis machine, what brand, so what machine and controller might you be using? That's one question I have for you all. Another question that I have is, what software or how are you programming the machine currently? So just so I have an idea of who's with us today and what types of machine and software you guys might be using. So thank you so much. All right, we got Ron from Minnesota here, so nice to see you. We have questions about when our next release is happening. As you guys know, Advantage Plan members, you guys get the upgrades, the updates. So as part of your Advantage Plan, you get all our training events and the service, the updates for the software, but also the upgrades. So 35. 35 will be coming out here. We don't always release the date, so I'm not sure, but it is an IMTS year, and I'm sure we'll see 35 for IMTS this year. Okay, very good. So again, I just kind of want to go through in this example. The first thing I do is I set up some index systems. Index systems, they work the same way they would in 4-axis, okay? One of the things that you should pay attention to when selecting an index system in 5-axis, a lot of times we'll just pick a surface in order to establish an index system. But then we're kind of leaving the chance the X direction and the Y direction. Okay, so a lot of times when you're doing 5-axis positioning, depending on the post processor and the machine configuration and the different formats for posting like coordinate rotation, etc., it becomes more important to use more of a coordinate system. So this way you can establish your X and Y direction as well. Okay, so I don't know how familiar you guys are, but you should be with creating coordinate systems. You can right click in the UCS area, click Add New UCS. From here, these are all the methods that you could use in order to create a coordinate system. And you can use something like a planar face like we've done here, and then you can come in and modify if you want to change what direction the X might be. Okay, you could swap that direction or what direction the Y might be. All right, so it's just something to be aware of. When you're establishing index systems in 5-axis, it's a good idea to utilize a UCS and get familiar with the options to edit the UCSs to establish them. Okay. All right. So where do you locate the index systems, or how do you add one into your tree here? So if you right click on the machine setup and you come down to additional functions, you can go to where it says add index. Okay, so this is one location. Okay, and then you'll get to the selection manager so you can pick the surfaces and decide where you want to index. Okay, another place you can get to it from is over here. So when you're in the milling in a milling job, there's the milling tab. So along this ribbon bar, there's another area where you can add an index. Okay, so either method would work. All right. Once you establish an index system, you can load machining features below it. All right, so you have the ability to establish an index system, which is really setting the Z direction, okay, the Z normal. Again, when we're in 5-axis, it's also setting X and Y orientation, right? But it's establishing the Z, and then the features child to that Z, they're all normal to that face, okay, or normal to that index system. All right, so you can see we have another one here, and this is normal to that boss there. You can see we're coming in and drilling. All right, and then we have another one over here. All right, so that's the first topic we're talking about with drilling. A lot of 3+2 machining, you're just going to index to a face and then establish an index system and then load machining features below it. All right. All right. So let's go ahead and run that through as an example. So I'm just going to take my model, Control C, all right, to copy it. I'm going to go to a new file, and then I'm going to paste it. All right, so here's our file. Now I'm going to get my job set up here. So I'm going to right click on my CAM defaults. We're going to do new job. All right, this is going to be, let's just use one of the generic 5-axis machines. So we'll go with a Haas UMC. All right, kind of a popular machine. From here, we're going to run the stock wizard. We'll pick our workpiece. And then for the stock, I'm not really concerned about roughing right at this stage. So I'm going to use the solid model as the stock. So I'll select that, click calculate, and then choose next. All right, so that way we're not worrying about roughing material at this moment. The next thing we want to do is establish our zero. The zero on your part really is going to depend. There's two scenarios, or I guess there's a couple of different modes for 5-axis. So depending on your machine controller, the way it's configured, and the support of the different modes will determine how the post processor is configured, and also the importance of where your zero position is going to be. In this example, I'm just going to put the zero at the bottom of the part where it's located. Now, there's another reference position here, and we'll talk about this in just a moment. This reference position, what we're going to use this for is to move the part around on the virtual machine. Okay, so we're going to just click OK on this for now. So we have our job. We have our job. We have our machine. That has its post. Here's our tools, right? We have our setup, our zero position. All right, so now what we want to do is establish an index system. All right, so we're going to right click. We're going to go to additional functions and insert index. From here, we can pick on a face that we want to index to. So I'm just going to pick on that surface there, and then I'm going to choose OK. All right, so now we've established an index system. Once we've established this index system, we can start loading machining features. So it could be any of the drilling type routines, or even the 2D and 3D type routines, okay? So in our case, we're gonna just say drill hole. We're gonna select geometry, and then we're gonna pick this inside cylinder here. So you'll notice you get a nice preview of the diameter of the hole and the depth of the hole. All right, and then you also see an arrow direction, so it's showing you what direction it's going to be drilling in. All right, from here we're going to choose OK, and you'll notice that this is just the standard hole wizard at this point. All right, so we're going to just decide what operations we want to apply to this. You know, whether we want to spot it and drill it. Okay. The spot drill we're going to use its parameters. The drill we're going to use its parameters. Okay, if we want it to be a pecking cycle or not. This is all the same. We're going to just hit compute, and we'll get our hole drilled here. Okay, we're going to right click on the operation and choose backplot. This way we can plot through and see what's going on. All right, and I don't know, tell me, do you guys like the ability to turn off the different components of the holder in the tool when we're backplotting? I've actually found this to be pretty useful. And I also like to be able to toggle the different modes. I find this is helpful to be able to visualize what's going on. All right. All right. So that is our spot. We're going to go ahead and close that one. Over here, we're going to backplot the drill again. So we'll just do the same thing. We'll right click and choose backplot. And then we can click through this and see exactly what's going on. All right. So that's drilling one hole there. Now, if we want to move to a different face and be able to drill, so let's say we want to drill these holes here, we would just establish another index system, okay? Let me pop this out for a second. All right. Okay, so again, we'll just establish another index system. So we'll right click, additional functions, add index, pick the face. We're going to choose OK. From here, we'll right click on this and we'll load in our drill routine. We'll select our holes, say OK. Again, define our strategy. Spot drill, its parameters, drill, its parameters. Okay, all right. Now, yeah, as you guys should know, if you want to adjust feeds and speeds here, you can always go to these flyouts and be able to adjust the feeds and speeds. Let me see here. We can uncheck this here, and then you can adjust your feeds and speeds for your operation. So this is kind of nice because instead of like thinking about the speeds and feeds first and then entering it and then selecting the geometry, really you can get the toolpath set up there and then be able to modify that as you go. All right. I also really like this expanded CAM tree, the ability to blank these operations, turn them on or off at one time, and also to be able to post code for, I guess I don't have a post for that one, to post code for a single operation. You can just post one of them. And then the other thing to be aware of as well is in this window too, once you post your code, you can copy and paste out of there. Let me just get a generic one. Okay, so post. I guess the directory this one is set up for. Let me switch to just the generic one. Okay, so yeah, you can get this code over here. You can Control C and Control V and be able to paste that into Notepad or the editor or into a program. All right, so I just wanted to make sure you guys were aware of that. I find that to be a useful feature. Okay, let's go back to the Haas for a second because I want to see it in simulation. All right, so we've set up some index systems. Okay, and so we have one here and we've done some drilling. Okay, now we have one here and we're doing some drilling. So let's just take a look at what it looks like in simulation. If you guys have any questions about 5-axis drilling, 5-axis deburring, or 5-axis porting, go ahead and just put them in the question section so I can see what you guys are thinking with. Every question is a good question. Doesn't matter what it is. All right, very good. Okay, so here we're going to just go to workpiece focus, turn the machine housing off, and be able to play this through. That went a little fast, so let's slow it down a little bit and restart so we can see the spotting and then the drilling. Let's get that out of there. All right. Let's go to the machine now. One of the things, having all these models as your machine definition, I mean, it's cool looking, not so necessary, and it is a resource demand on your system. So generally, when you build out the machine housing, you can tag certain components as the housing, and this will give you the ability to show or hide the housing so you can just focus on some of the components. My recommendation is if you're building the machine and you're adding in the models so that you can check against it, to kind of minimize them the best that you can, and really have the ones that would be of a collision consideration. All right, so here again we can see the part, the 0 is on the bottom of the part, so the 0 for this job is the center of the table here. We can see how the part has been indexed to the first space that we're working with. We're going to come through and be able to drill, and you'll see that it will position as it goes between the two different index systems. Okay. If there's any questions about establishing an index system or loading a drill routine child to that index system, go ahead and ask away. Otherwise, I'm going to look on to the next topic here. Okay, so I'll give you guys just a second. If not, no big deal. Okay. All right, so the next thing that we want to do is we want to use hole recognition. Recognition, it's a way to drill and have the software find the holes for you. And it uses a knowledge base, and it can be customized so you can build some logic into it. So like all automation tools, understanding what it does and how to best use it. One of the things that I like about the hole recognition is it does find all the holes for you, and then you can decide which ones you want to work with. You can edit them and how you're going to process them. All right, I'm just going to create a new setup so we can see the differences. All right, in this setup here, I'm going to leave everything the same, but for the work offset value, again, this is a shift value that I can use for simulation, so I can move the part up, and I'm going to move the part up 4 inches off the table, and then I'll choose OK. So setup 1 and setup 2 is basically the same. One of the things that I do want to do is I want to change this to work offset number 2 and say OK. All right, so a quick pause here between setup 1 and setup 2. This is let's say 55 or 54, and this one's 55. One of the ways that you can speed up programming is copying and pasting features from one setup to another. Okay, so taking something from this setup, copying it, and then pasting it into another setup. Now, in the past, if you did that, whatever the setup number it was originally, it would keep that number. But you'll notice in this version, in the current version, if you change your work offset number, you're going to get warned about it. And then from there, you have the ability to decide what you want to do. So yeah, I'm going to update this one for work offset number 2. And if we get in here under the, where does it have it? Under posting, it's going to have it as work offset number 2. So again, just something to be aware of. If you have multiple features under your setup, if you edit that setup number, so if we change this to a different number, okay, it will ask you if you want to change all of them or which ones you want to change or not to the updated setup. So again, very useful features as you're making changes in the shop to accommodate for different jobs. Maybe you're changing your work offset numbers. You should be aware of that, and hopefully something that is useful for you guys. Okay, so let's go ahead and get rid of that. Again, we have another setup here. The only thing that is different is the distance that we have it off the table. We'll say OK. All right. Other than that, what we're going to do is go to the hole recognition. All right. We're going to select the whole body, and then we're going to choose OK. All right. So you'll notice right away we get a warning, and it says no holes were found. So essentially what it's saying is along Z for this setup, there were no holes perpendicular to Z, right? So if you're going to use hole recognition on a 5-axis job, okay, what you would have to do first is establish the index systems. Okay, so we're going to add an index, and we're going to establish all the faces that we want to look at for drilling. Okay, so we'll add another one over here. All right, I'm going to add another one over here. Okay. So now that we have all those the indexes established, now if we run the hole recognition, it will use those index systems to figure out which holes they can drill. All right. Now, again, what's nice about this, if you think about it in the past, how would you sort holes? You might select by radius, or you might do a CAD preparation stage where you separate out the geometry. What's really nice about hole recognition is it just finds all the holes that it can, and then it displays their information in this table here, and then from this table, you can go in and work on each of the individual uh, cycles, and then you have the ability to turn them off if you just don't want to do that one. You can turn them off or turn them on and adjust them. And you'll notice there's a preview in the background so you can see which hole you're working with. Now, the other thing is, as far as like what type of feature is created, this is based on the knowledge base. So you can establish logic in order to control how the system processes those holes and what feature types it calls. Um, again, there's a basic knowledge base built in there. It's a rules type assessment, and you can customize that again to automate this process. Okay, so in my example, I'm going to turn off the larger hole here, and I just want to drill the smaller holes. Again, if I want to change what type of feature, again, what operations would be called with it, I could do that here. Once I'm done, I'm just going to hit compute. Because I turned the other ones off, it only drilled in this section. Okay. So again, another way you can utilize this is to be able to use the hole recognition. You establish the index systems you want to look at, and then again, you can target just the hole sizes you want to work with, right? So in this case, I broke up the first group. I did it with these ones here. The second group, I programmed both of the larger holes at the same time. Okay. All right. So the takeaway there is if we back up to drill on different faces of the part, establish an index system. Now I'm kind of cheating where I'm just picking the faces, but most likely, depending on the geometry and the setup, you're going to want to use a coordinate system for that. All right. And again, to create a coordinate system, you can just right click in the UCS area, add new UCS. There's a number of methods here. You can utilize one of the methods to establish a coordinate system, and then from there you can use modify if you want to modify the axis orientation, right? So you're making sure that as far as which way X and Y and Z will be orientated for a 5-axis move. Okay, so all right, so back up on that. So to establish an index system for 5-axis drilling, you can use index systems to establish an orientation, and then from there you can drill. Okay, when you're picking, how you establish it, what geometry you pick, you can pick surfaces, but that's not controlling your X and Y, right? So instead of picking a surface, in a lot of cases, it's going to be recommended, especially for 5-axis drilling, to create a UCS. Okay, and creating a UCS, you right click in here and add the UCS and use the methods. Okay, all right, so we create an index system and then it's normal drilling. Okay, the next scenario we gave here is where we want to use hole recognition. So it's essentially the same workflow, but the difference being is when you're selecting your geometry. In our first setup here, we went through and picked what we wanted to machine. In the second workflow, we use the hole recognition to find holes that we want to machine based on the established index systems. Okay, and then from there, we can turn on or off the holes that we want to work with. We can change the sizes of them, and we can also change what type of operations are associated with it. Again, this is done through a knowledge base, which is rules, and you can adjust those rules to better optimize your manufacturing. Okay. All right. The last one we're going to look at here, this is actually, let's turn this one off and run the simulation because we want to see the difference between the two different setups, right? So the first setup, the part was right on the table. And the second setup, it looks like we have a ghost body associated with our 0 as we move this. But on the second setup, you can see the part is now 4 inches off the table. Some other geometry came with it. Probably didn't want that, but again, showing how you can move where the part is on the table using that work offset. All right, some post processors, they use that value for length offset calculations in 5-axis. Other post processors, they don't need to utilize that. When you submit your post, or if you're building a post yourself, you're going to get into the multi-axis posting section. Inside of the multi-axis posting, you have some different ways in which we're handling the movements for 5-axis output. And this is specific to your machine and controller. Okay, if you, in my opinion, if you have a 5-axis machine and you're programming it, I'd highly recommend the 2 Launchpad courses we have. We have one on writing post processors, and we also have one on building 5-axis machines. So if you haven't reviewed those, I would highly recommend it. It will really help demystify a lot of these topics. Okay, the next one that we have here is the multi-axis drilling. Okay, so what's the workflow there? We're going to right-click on our setup, and we're going to add an additional setup. All right, we're going to edit our setup. So I'm going to do a double click. If you don't have the double click editing option on, it's really easy to set up. If you want to just double click to edit within the CAM tree, double left click, you can do that by adjusting your user interface, the tree behavior, double click edit. Okay, if you want to go to the previous method, you can set that here. Otherwise, I would use this double click edit. All right, I find it to be super cool. All right, so we're in here. We're going to edit this. We're going to do the same thing, or actually this one we'll leave at 0. We can make this a different work offset. We're going to say this one, actually, I'm going to move it in X and Y, just so, again, we can exemplify this function. All right, so now we want to drill these holes. We're going to right click. We're going to go mill drill hole. All right, we're going to select our geometry, and we're going to pick the holes that we want to work with. So right now I have my stock showing, so I'm gonna finish this real quick. If I want to turn the visibility of my stock off, I can just turn that off. That makes it a little easier to see. The other thing I can do, I can left click in the CAD space and hit S on my keyboard to toggle shading on or off, or W for our UV lines, and that will just aid in selection. All right, we're going to come back to our hole feature and reselect. Now, in order to get to the multi-axis drilling, you have to go from hole type and working top down, and we're going to just go to multi-axis drill. From here, we're going to select the cylindrical tubes, the cylinders for the holes that we want to drill. So we'll select those there, and then we're going to select these over here, and we'll say OK. I need to add some operations, so I'm going to go back to my machining strategy and add an operation. I'm just going to do a drill here. I'm going to compute it and let it find the holes and drill it. Okay, so we can see how it's drilling these 2 different groups here. I'm going to hide this setup. Let's right-click on the drill and go to backplot. Again, this will help us see how they're set up. Now, I selected the geometry after not loading operations, so it didn't pick up that whole size. So let's actually go through that again from the beginning. But before I do that, I want to talk about the linking between the one group and the other group. Okay, so if we edit our feature here, or operation, we need to change our group retrack. Okay, so that's going to be at the feature level, group retrack, and you have a couple of different modes here. So I'm just going to change it to a different mode just to kind of show how that works. In this case, I did create a linking move that is within the part. All right, so that's no good. Let's double click, edit that. Let's go up to here. Let's make this greater. Let's go 8. This angle step move for rapids, some machines, they like lots of points, some machines don't. So this is something that you can use to adjust the segment lengths for G00 moves as it's positioning from one face of the part to another. I'm sure there's probably some mapping in here where we could map that to a high feed or use the toolpath editor to map it to the high feed. Again, it depends on the machine, but we're going to just adjust this group retract and recompute. So now we can see it's much higher there. All right. We're going to back plot from this side on over to that side using the different group retract method. Okay. All right, so we want to get back in here and let's actually delete this guy and just go through it from start to finish. So we're going to right click, mill drill hole, select geometry. We're going to come in here and pick the faces we want to work with. For holes, it's going to be the cylinders. You can pick different hole sizes and it will put them into two different groups. So that is fine, but I just want to stay focused on this. I'm going to go to multi-axis drill here. Again, one of the things that you'll see is these arrow and directions. Sometimes, depending on the geometry, the hole can be pointing the wrong way. So if you pick one of these, you can see how you can reverse the arrow. Okay, so if the arrow isn't going down into the part in the direction you want, you can select the face. You can see it highlights to a different color, and then you can invert it. All right, we're going to say OK on that. We're going to say it's blind. We're going to add, let's just do just the drill. All right, let's go to our group retracts. We already know, well, this is set to plane. Let's go to this. Or nope, not that. Let's go to this. All right. Okay, now you can see how it's going to link from one area to the other area. All right, so those are our 3 topics for drilling. If there's any questions before we move on to the next topic, go ahead and let me know. If you guys got a good shop joke you want to share, that'd be great. Always interested in hearing some of the humor of you guys. I'm going to go through and simulate this one here, so let's run this through a simulation. Okay, again, this one you can see how the part is moved off to the side of the table. All right, again, that was done with that shift value. We can see how it repositions and drills again. Let's restart it. All right, so that's that one. Let's just close it. We'll turn that one off, turn this one on, run our simulation. Okay, this one again, instead of shifting in X and Y, we use Z, and you can see how the part is off the table there. Okay, with the index systems, you can see the difference between the linking. The other one was interpolated, and this one was clearance and then direct move. So a little different motion on the machine. Something you have to pay attention to for your clearances, right? But again, we've gone through and drilled all our holes here. Let's go ahead and close this one off. And we'll do the last one. So we'll turn this one on, turn that one off. All right, this one's on the center of the table. All right, something to consider. You have the job set up, that machine is busy. Maybe you want to run the job on a different machine. You can switch to a different machine. Let's go to a head style. Let's go ahead and run this one through simulation and see what we get. So again, similar style. This one is a head configuration. We probably need to get this part up on the table a little bit higher. But again, showing indexing here. All right. Let's go to a different style here. Let's try this porting head. Let's see what this one looks like. All right. Let's close that out. And there we have some 5-axis drilling. Listen, do we want to look at some code? I just have the generic one. The generic BC. Oh, let's turn this on. Oh, I didn't want to do that. Look at some of the codes here. Let's turn this one off. Turn this one on. Oh, I keep missing it. Wrong button. This code looks a little bit different. We can kind of see. No, that's pretty much the same. All right, let's turn that one off. That one's quite a bit different as far as the multi-axis drilling, right? So this one's all done with tool motion here on this post. This one, let's turn this one off. This one, position. This is done with movement as well. Trying to see if there's a CAN cycle. Here's a CAN cycle in here. Okay. Let's move on to the next one. Let's go to 5-axis deburring. If you guys like this topic, if there's some good takeaways, if you can share them with the group, that'd be great in the questions area. Otherwise, let's move on to the next one. So let's close that one out. Let's see here. This one, again, you can, as far as fixtures, setup plates, things like that, you can download the models from a lot of the vendors, 5-axis, Jurgens, etc. And it's nice to have the models so they're the actual size and you can check for collisions. But a lot of times, just some basic geometry that represents the area of your fixture or work holding is easier. It doesn't take as much memory to process a single body versus multiple bodies in simulation.